Good day. We're going to pick back up from yesterday when we were talking about probabilities of events. Now we know from probabilities of events that we're always looking for the number of successful outcomes out of the total number of outcomes. We're going to add to this another strategy that we have, something that we call complementary probability. Now complementary probability, let's get on to word, complementary probability. We're looking at two events or sets of outcomes that are complete opposites. The word complementary is like they work well together. Going back to geometry when you had complementary angles, together they filled out a right angle. So complementary angles are two events that completely fill out all of the possible outcomes for our probability. Things that we know, by definition, probability at most everything happening is 1. And if we have two opposites happening, it's yes and no being put together, we're going to have the full set. We're going to have 1. What this means is that we have the probability of two different sets, A and B we'll call them, always equal to 1. That gives us that A and B are opposites. And A would be every possible outcome except for whenever B is happening. Excuse me, that gives us B is the same as not A happening. B happens when A does not happen, or A happens when B does not happen. But I'm going to focus on this, that B is not A. Taking that idea, this gives us that the probability of A added to the probability of not A happening equals 1. Or we could rearrange that to say that A, the probability of A is 1 subtract the probability of A not happening, or probability of A not happening is 1 subtract the probability of A. So there's a formula for what we have, complementary events. Seeing this in action helps to explain it a little bit better. It's very simple when we think about the sample spaces, the set of all possible outcomes that we have. Let me go into our first example now. We're going to roll a die. Find the probability that the value rolled is not 5. Now we know pretty clearly that we can figure this out. But using this idea, and this is going to help us later on, the possible outcomes for a die are 1, 2, 3, 4, 5, or 6. Each individual value has a probability of 1/5. Now we want the probability of not 5. Based upon this idea, well, we know the probability of 5 is 1/6 because there are 6 sides on a normal die, and 5 is one of those sides. Not 5, probability of not 5 is then 1 subtract the probability of 5, giving us 1 minus 1/6, which is 5/6. That is the sum of everything else that's out there. If we think about the set of all possible outcomes, the sample space a die could give us could be 1, 2, 3, 4, 5, or 6. We do not want one of them. We want everything else. Well, we take the full 6 items that are there and we take away the one that we don't want. So we can use this idea of complementary events. We can use it to find things that the opposites are sometimes easier to find if we know something straightforward. I'm going to look at a second example now. We're going to flip 4 coins. Now we saw yesterday with an example, when we are flipping 4 coins, there are 16 possible outcomes. I want the probability that at least 1 coin shows heads. Now saying at least, that's the key phrase here. At least, well, what could that mean? We could have, to be successful, 1 head shows and 3 tails. We could see 2 heads and 2 tails. We could see 3 heads and 1 tail, or all 4 of them could be heads. At least means that we have to look at all of these different possibilities. Rather than going through, we can think that there are 5 possible outcomes for the number of heads that are seen. We could see 4, 3, 2, 1, or even 0 heads to show up when we flip 4 coins. We want this set here. We want how many different ways are there for 4, 3, 2, or 1 head to show up when we flip our 4 coins. We want that set. We want everything except for 0 heads. So this idea of at least, it is everything except for no heads. Thinking we want some number of heads to show up, something is the opposite of nothing there. So the probability of at least 1 head is the complement of the probability of no heads. Figuring this out, probability of at least one head would be 1 subtract the probability of no heads. That's all tails. That is 1/16. We have 15 over 16. We can think about this, the idea that when we see the words at least, we should think at least something is happening. Something is the opposite, is the complement of nothing. So when we see the idea, the probability of at least something, and this is the key that we're going to be looking for words along the way. We see the probability of at least something happening, it will always be equal to the probability of 1 subtract nothing happening. You see those words at least, probability of at least something is 1 minus the probability of nothing happening. And quite often, the probability of nothing happening is much easier to find than at least, where we have multiple events happening together. Going back to this, finding the probability that nothing happens in this case, well, there's 1/2 probability for each coin, showing tails. Combined together, we would have 1/2 times 1/2 times 1/2 times 1/2, giving us, going back up top, 1/16. One computation, we found one item, not 4 separate items that we had to combine. Point that we have for today, complementary events, the probability of at least something is 1 minus the probability of nothing. Or, the probability of A is 1 minus the probability of not A. Try it out. There's a few problems up on the classroom site. Good luck.